In this lecture, I want to introduce you to different types of voting methods. I want to do this to give us some examples to work with throughout the course. So there are many different types of election methods, many more than we'll have time to discuss in this course. So here's just a listing of some of them that I've been able to track down or that I thought of when I was preparing the slides. Of course, many more exist. We won't have time to talk about all of them. Some of them were created by mathematicians and political scientists just to illustrate some general phenomena or illustrate some abstract point. Other methods, like the ones that I have highlighted in red here, are actually used by various societies to hold elections. So we'll talk about some of these methods in this lecture. So there are three types of methods we're going to look at here. We're going to look at scoring rules, multi-stage methods, and non-ranking methods. And these each differ in the information that they require from the voters, but also how they calculate who the winner is, even if they're given the same information. So let's start with scoring rules. And the way scoring rules work is they require the voters to rank all of the candidates. Then each candidate is given a score from each voter, and that score is calculated from the ranking that the voter gave. That's the voter's ballot. So two scoring rules that I want to talk about. The first is plurality rule or plurality vote. This one is also known as first past the post. This is a very common method, very easy to implement. Every voter selects one of the candidates, and the candidate with the most votes is declared the winner. Now you might wonder, why am I classifying this as a scoring rule? Because I said that the voters are required to rank all of the candidates. Well, the general point is that for a scoring rule, you could, if you wanted to, simply ignore a large part of the input received from the voter. So the voter ranks the candidates, but you only focus on which candidate is ranked top. The second method is Borda count. And Borda count doesn't ignore any of the data given by the ranking from each of the voters. And what Borda count does is each voter ranks the candidates, and you have to rank the candidates in a linear order. So, which that means that there are no ties, and then you give a score. The candidate who is ranked first by a voter gets a certain number of points, and Borda gives a specific score you have to give. So if there are n candidates, you get n minus 1 points if you're ranked first, n minus 2 points if you're ranked second, and so on, and 0 points if you're ranked last. So let's illustrate these methods with an example. So here's our data. We have a society of 14, 20, 21 voters altogether. As a reminder, this means that there are 6 voters that rank candidate C above B above A. So these 21 voters, these are the rankings that they submit. And let's calculate the winner according to these two different methods. So plurality vote, what you do is the top candidate gets 1 point and all of the other candidates get 0 point. Whereas Borda count, since there's 3 candidates, the top candidate is going to get 2 points. The last candidate gets 0 points, but the second place candidate gets 1 point. So for plurality, we can see very quickly, it's easy to calculate the winner. You essentially ignore all of the lower ranked candidates, and we see that candidate A gets a total of 8 points, and so should be declared the winner. Coming in second place is B with 7 points, and finally C comes in last with only 6 first place votes. What about Borda count? Well, Borda count, you get 2 points if you're ranked first, 1 point if you're ranked second, and 0 points if you're ranked last. So we can now go through and we can calculate the Borda score for each one of the candidates. So we'll start with candidate A. So the Borda score for candidate A is going to be, well, A gets 2 points for being in first place from these 8 voters. So the 8 voters rank A in first place. So that's going to be, oops, sorry about that. That's going to be 2 points from 8 voters altogether, and then 0 points from the remaining 13 voters. So plus 0 times 13, which is a total of 16 points altogether. So A receives 16 points from according to Borda. The Borda score for B, let's see. So B gets 2 points from the second group of 7. So that's 2 times 7 points. Plus, well, altogether, this voter plus these 6 voters, they rank B second. So that's 7 voters give B 1 point. Finally, 7 voters, this middle column here, gives B 0 points. So that's 0 times 7. So that's 14 plus 7 is 21 points altogether. And finally, what about candidate C? Well, candidate C, who came in last, got the least number of first place votes. So C gets 2 times 6 points from this last column. But C does really well at the second level. So 14 people rank C second. So that will give C an additional 1 times 14 points. And finally, only 1 person ranks C last. So that's 0 times 1. So altogether, that's 12 plus 14 is 26. So Borda recognizes that, in fact, a lot of people actually quite like candidate C. They rank C second. And so C is declared the winner with 26 points. So note that plurality vote and Borda count, they give exactly opposite orderings of the candidate. Plurality ranks the candidates A above B above C, whereas Borda ranks them exactly the opposite, C above B above A. Okay, so these were 2 examples of scoring rules. And now let's look at multi-stage voting methods. And the way I want to think of these multi-stage voting methods is, again, I want the voters to rank the candidates in a linear order from their first place to their last place. But the calculation does not proceed by assigning scores to the candidates. Rather, the way the candidate who's determined to be the winner happens in stages. So at the first round, you identify one candidate or a set of candidates, and then you remove that candidate from consideration, and you move on to the second round. And again, you look to see who should be removed from consideration, and you remove that candidate from the second round, and all the way down to till you come up with a single winner. Now, I just want to make one quick point about these different stages. Note, for example, plurality with runoff proceeds by each voter ranks the candidates, but then the top 2 candidates, the candidates who receive the most first place votes, move on to the second round. And then in the second round, we just check to see between each of those 2 candidates. We imagine the election was between just those 2 candidates. And we look at the original rankings and we see which of those 2 candidates receives the most votes. And whoever does is declared the winner. But of course, we could think of these runoff elections in a completely different way. We can conceive of them as essentially a separate election, which is what actually happens in practice. This is what happens in France. You hold an initial election, and then you move on to the second round and you hold a completely separate election. And the voters are not required to have the same ranking over these 2 candidates in the 2 elections. But for purposes of illustration, we're going to conceive of it as the voters rank the candidates and they keep those rankings between the two runoffs. So that's plurality with runoff. The Hare rule is, you can think of it as a generalization of plurality with runoff. So what the Hare system does is each voter ranks the candidates, and then you find the candidate with the fewest first place votes. And then that candidate is obviously not going to win, so you remove that candidate from consideration. And then in the second round, you again find the candidate with the fewest first place votes, and you remove that candidate from consideration. Then you move on to the third round, and you keep going until one of the candidate receives either an absolute majority or maybe is the only candidate left, or is the tie. Ties might happen as well. So, of course, if there's only 3 candidates, then plurality with runoff and the Hare system are exactly the same. They will give you the exact same set of winners. But as we'll see, if there's more than 3 candidates, they may give you different winners. And finally, Coombs' rule looks in the opposite direction. So Coombs asks which candidate receives the most last place votes. So which candidate is liked the least. Then you remove that candidate from consideration, you move on to the second round, and you keep going until one candidate is left. There's only one candidate left, or a group of candidates is tied. So let's take a look at an example. So here's our data. Now it's different data than what we had before. So 12, 16, 19 voters altogether, and we have 4 candidates. So in plurality with runoff, you note right away that candidates A and B receive the most first place votes. So in plurality with runoff, they are the winners of the first round, so they move on to the second round. And what happens is, since we remove candidate D and C from consideration, those votes are transferred to the votes in the second and third column are transferred to B and A, respectively. So now in the second round, we see that candidate A gets 10 votes, whereas candidate B only gets 9 votes. So A is declared the winner because A receives more votes than candidate B in the second round. What about the Hare system? So the Hare system starts off in exactly the same way. You look at the number of first place votes, but rather than just jumping to the top 2 candidates, we look at the candidate that received the fewest number of first place votes, in this case it's candidate C, and remove that candidate from consideration. So C's votes in this last column are going to be transferred to D. And now in the second round, D actually ends up with more first place votes than candidate B. But D and A are tied, so we're going to remove B from consideration, and B's votes are going to be transferred to candidate D, at least in the second column. And then finally in this last round, because only 2 candidates left, one of them will receive an absolute majority. And in this case, D is declared the winner with 12 votes. Now, looking at the Coombs rule or Coombs system, we, rather than looking at the first place votes, we look at the last place votes. Now, the candidate that receives the most last place votes is, in some sense, liked the least by the voters. So in this case, it's candidate A with a total of 9 last place votes, and that candidate is removed. So that candidate's last place votes are transferred upwards. So we look at who these 2 columns rank third, and we see now that D ends up with the most last place votes, with 12 total. So C gets 4 last place votes and B gets 3 last place votes. So in that round, candidate D is removed and all of D's votes are transferred to C, and we see that B is declared the winner because B has only 3 last place votes, while C has 16 last place votes. So B is declared the winner. So in this one example, we see that with plurality with runoff, the Hare rule, and the Coombs rule, they each give you different winners. So plurality with runoff selects winner candidate A, the Hare system selects candidate D, and the Coombs rule selects candidate B. So finally, I want to look at 2 methods that can be classified as non-ranking voting methods. And the reason I classify these as non-ranking is because the voting system asks for information that is qualitatively different than ranking the candidates. So negative voting, this allows the voters to decide if they want to vote for a particular candidate or if they want to vote against a particular candidate. So you take points away from a candidate. In some sense, this is similar to a scoring rule where you allow negative scores rather than only positive scores. So the idea is that voters are allowed to choose just one candidate, but they also then say, do I want to vote for that candidate, or do I really not want that candidate to win? So I want to vote against that candidate. Or you may allow the voter to abstain, so assign 0 points. Now, negative voting can be generalized, because one way to conceive of negative voting is you allow the voter to select just one candidate, or to select a set of candidates, every candidate except for one particular candidate, and then the voter that receives the most votes is declared the winner. Approval voting allows the voters to select any subset of candidates. So intuitively what that is it's any set of candidates that the voter approves of, that the voter thinks could do a good job or should win the election. And then the voter with the candidate with the most votes is declared the winner. So this was a very quick and brief overview of different types of voting methods. And I wanted to get these on the table to give us some examples to work with when we illustrate various general properties that voting systems might have. So with all of these voting methods, one question should immediately pop into your head, namely, which of these voting methods is better? Which one should I use? Should I use plurality rule, or should I use something like Borda count? How can I go about comparing these different voting methods? This will be the topic of many of the lectures in the remaining, the rest of this week, and probably some of next week as well. We will discuss these general issues, how you can go about comparing these different voting methods.